So hello everyone, my name is Gaurav Urse and today we see the example for matrices is the diagonalization matrices. The diagonal matrices are denoted by P and we have formula for this, the P inverse A and P. Um, we need this formula for this given example. The example will start show that the matrix like A is something matrix is diagonal, find is the transforming matrix and diagonal matrix. The first of all we see a matrix and we see a formula like a characteristic equation. Equation is mod of A minus lambda r equal to 0. And we have a formula for solve eigenvector like lambda cube minus s1 lambda square h2 lambda minus mod of A equal to 0. So first of all we see here s1. The s1 we calculate for the these three terms additions like 8 minus 3 plus 1. So 8 minus 3 5 and plus 1 6. So we get the s1 like a 6 for the s2 minus 11 plus 14 8 equal to 11. Then we find the determinant of A. Value in these equations lambda cube h1 value we get 6 lambda square, then h2 value we get 11 lambda and the determinant of A 6 put the value in calcium and we get a value like lambda 1 equal to 1, lambda 2 equal to 2 and lambda 3 equal to 3. So, this all value lambda 1, lambda 2, lambda 3 are the distinct value. Then we find the diagonalization. So first of all we see lambda 1 equal to we have a formula for this. One for this the given matrix we get the value like 7 4 3 minus 8 minus 4 minus 4 minus 2 minus 2 0 and side we have value like x1 x2 x2 equal to 0. So now we use the Cramer's rule. So the Cramer's rule say that we take any two rows, like we take a first and third row, second and third row, second or first row. We take a randomly any two rows. So we take a first and second row. So first and second row we get and multiply by side by side x1. So 7 multiply x1 7, then minus x2 minus x3 equal to 0. Then we multiply 4 into x1 for x1 for x2 to x3 to 0. We have the Cramer's rule. So we solve this equation by like x1 by x2 and x3 equal to 0. The first is a plus, second is a minus, third is also plus. Then we solve the x1. Then we solve the x1. The remaining x2 and x3 is the value. We solve this equation. We take the like minus 8, minus 4, minus 2, minus 2. Then we drop the x2 value. Only take the x1 and x3 value like 7, 2 and minus 2. In x3 we take drop the x3 value and take only x1 and x2 value. The x1 7 minus 8 and 4 minus 4. Then we solve these equations. The x1, the 8 to the 16 minus minus is plus 16 and 4 to the 8 minus minus plus. Then x2 we get 7 to the 14 and 4 to the 8 minus minus plus, then 4 to the 8 minus minus, and x3 we get the value like 7 for the 28 and 8 for the 32. 32 is minus minus plus. Uh, 16 minus 8, 8. x2 we get 6 and x3 we get 4. So minus minus cuts and we get a value like x1 is 8, x2 is 6 and x3 is the 4. So all value are divided by 2. So we divide this equation by 2. 2 for the 8, 2 3 is the 6 and 2 to the 4. Then we write this equation like this: x1 equal to 4, 3 and 2. We get this value for x1. This is the same we apply like lambda 2. The way our lambda 2 value is now. We put this equation, we put eigen's value is lambda 2 equal to 2. Then we divide the whole A equation minus 2. We get a formula like A minus lambda I into x equal to 0. We minus lambda 2 in a given matrix. We get the equation like 8 minus 2 is 6, minus 3 minus 2 is minus 5, and 1 minus 2 is minus 1, minus 8, minus 2, minus 2, minus 4, 4, 3, and x1, x2 and x3 equal to 0. Equation by also Cramer's rule. As we first of all we see this upper side by Cramer's. We get two rows, like we take a first, second, second, third, first, third. We take a first two rows like 6 x1 minus 8 x2 minus 2 x2 equal to 0. Then 4 x1 minus 5 x2 minus 2 x3 equal to 0. Then we put this equation as same. The x1 x2 x3 equal to 0. The minus 8 minus 5 minus 2 minus 2 6 4 2 minus 2 6 minus 8 4 minus 5. Then we get the value of x1 is 8 to the 16 minus minus plus 5 to the 10 minus minus plus, and then minus is minus x2 6 to the 12 minus 12 4 to the 8 minus 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 plus, we get the value like 4 to the 8 and x3 6 5 13 and 8 for the 20 minus minus plus 8 for the 32, we get the value x1 equal to 6, x2 we get minus 4 and x3 we get 2. Then all of this divided by 2, we divide by 2, 2 1 is 2, 2 2 is 4, 2 3 is 6, so we get the value like x1 by 3, x2 2 and x3 is 1. So minus minus cut. So we get the x2 equation like 3, 2 and 1. Then same as this process we proceed for the third equation. The third equation is like, now we put the eigenvalue lambda 3 equal to 3. The diagonal element by lambda, then we get this equation like, so we have a formula for this, a minus I equal to 0. Then we minus 3 for the diagonal element by given matrix, so we get the matrix like 8 minus 3 5, 8 minus 3 get 5, minus 3 and minus 3 is minus 6, and minus 1 minus 3 go, then minus 2 4 3 4 and minus 2, and this side we have x1 x2 and x3 equal to 0. Then we use the same as Cramer's rule. The Cramer's rule are says that we take any two rows, we take a first and second row, the 5x1 8x2 minus x3 equal to 0, then 4x1 minus x2 minus x3 equal to 0. Then I same as then we solve the get x1, x2 and x3. The x1 minus x1, x2 minus x2 equal to x2. So we put the x1 values like minus 8, minus 6, minus 2, minus 2. Then we put the x2 value 5, 4, minus 2, minus 2 and x3. We put the value like 5, x1, 4, x2 equal to 0. Then we solve this equation by this 8 to the 16 minus minus plus 6 to the 12 minus minus plus, then the minus is then x2 5 to the Then 4 to the 8. The minus 8 will be plus 8. Then x3 is 6 5 the 30. And 8 4 the 32. The minus will be converted by 42. X getting 4, x2 we get minus 2, and x3 we get 2. All our numbers denominator are divided by 2, so we divide by 2, like a 2 and the 2, 2 and the 2, 2 to the 4. So x3 we get 2, and minus minus are get cancelled, 1 1. Then we take the equation for this, p equal to in bracket x1, x2 and x3. Then we solve this equation like we write this in this equation like 4 2 4 3 2 3 2 1 2 1 1. So then we solve the diagonalization. Now we have the formula for diagonalization. So diagonalization is D P inverse A P. So we find the P inverse. We have P inverse. So let's we calculate value like minus 1 1 1 1 0 minus 2 1 minus 2 and 1 and 1 minus 8 minus 2 4 minus 3 minus 2 minus 3 minus 2 3 4 1, and the P is this matrix 4 3 2 3 2 1 2 1 1. We multiply for this three matrices. First of all, we multiply these two matrices, then multiply by this matrix. We get the multiplication is like 1 2 3 0 0 0 0 0, and that's one thing. This 1 2 3 is like eigenvector like lambda 1 lambda 2 and lambda 3. It's a given equation. Then we solve this equation.